Today's lesson is Unit 1, Part C. And today's topic is going to be solving systems of equations The last lesson was by graphing. This lesson is going to be by using elimination. So, the word that I see in elimination is to eliminate, and to eliminate means to get rid of. So we're going to be trying to get rid of one of the variables to solve for the other variable. Our goal is still the same here. We're trying to find that point of intersection. Even though we're not graphing like we were in the last lesson, the solution still means the same thing, even though we're not graphing. We're still trying to find that point of intersection. So let's take a look at what steps you're going to be following today. So first, here's what you're looking for. Look for the same variable or letter same number in front of that variable, different signs. So that's what you're looking for. Same variable or letter, same number or same coefficient, different signs. I mean, one has to be positive, one has to be negative. And then once you find that, your second step is add the equations and solve. Meaning you need to find out what x is equal to, you have to find out what y is equal to. And then we're going to write our solution as an ordered pair. So your solution is going to be an ordered pair. Even though we're not graphing, we are still finding that point of intersection. So I'm going to go over a couple of problems, actually 3. So the directions will say solve. Let's take a look at number 1. I've got 3x minus 2y is equal to 4, and 4x plus 2y is equal to 10. So let's take a look back here at number 1. We're looking for the same variable, same letter, same number in front of that variable, different signs. If I take a look at this first problem, do I have that? Well, the x's are different numbers. I've got y, they're both 2 in front of the y, one's a negative, one's a positive. That's exactly what I want. So once I have that, then I'm going to add the equations. So that's exactly what I'm going to do. 3x plus, now it's just combined like terms. 3x plus 4x is 7x, this cancels. 4 plus 10, that's giving us 14. Now I solve for the variable. Divide both sides by 7. I'm getting x is equal to 2. Now I found one part of the point of intersection. Now I have to find y. You have 2 options. You can substitute that 2 in here. You can substitute that 2 in here. It does not matter. Because I prefer to work with positives, I'm going to work with this bottom equation. So I'm going to take this 2 and substitute it in here. I could substitute it in here. It doesn't matter. Either equation. So 4 times 2 plus 2y is equal to 10. 4 times 2 is 8. 8 plus 2y is equal to 10. I'm going to subtract 8 on both sides. I've got 2y is equal to 2. Divide both sides by 2. I'm getting y is equal to 1. I'm going to write this as an ordered pair. So my solution is 2, 1. That means if I were to graph this original problem, if I were to graph this, put it in slope-intercept form, find the slope, find the y-intercept. graph both of those equations, they would meet at 2, 1. Okay, let's take a look at problem number 2. Let's see where we're going to put you. Let's go this way. Okay, number 2. I've got 2x plus y is equal to 5. And 3x minus 2y is equal to 4. Actually, I think I'm going to change that one. Let's do, that's very similar to number 1. So let's do 2x plus 4y is equal to 30, and 2x plus 2y is equal to 22. So 2x plus 4y is equal to 30, and 2x plus 2y is equal to 22. All right, so if I take a look at this particular problem, you can really eliminate either variable. It doesn't matter. I could do the x's or do the y's. It may be a little bit easier to do the x's because they're already the same number. The only issue is one's a positive, actually they're both positive. I need to make one of them negative. And again, it doesn't matter which two you make a negative or which equation you work with. We'll work with the bottom one. So in order to make this a negative, I can't just make it a negative and say, okay, I'm done. You have to take that entire equation and multiply through by a -1. So what I'm going to do is, I'm just going to rewrite this one. I'm not going to do anything with that. Just rewrite it. This becomes -2x minus 2y is equal to -22. Now I've got the same variable, same number, different sign. Now if I wanted to eliminate the y's, I could have just multiplied this bottom equation by a -2. If I did that, that would become -4. This would become a +4. This would become a 44, just to make these numbers the same, different sign. But we've decided to eliminate the x, so this is what we're going to do. Once you commit, you commit. You got to follow through with it. All right, let's add up these equations. The 2x and -2x cancels. I'm left with 2y is equal to 8. Divide both sides by 2. I'm getting y is equal to 4. So I found one part. I found the y-coordinate of the point of intersection. Now I'm going to take this 4, and I have two. Actually, I've got 3 options. I can substitute it in up here. Actually, down here. Over here, or up here. It doesn't really matter. I don't want to work with negatives. And it doesn't matter either equation. I think I'm going to choose this one. Let's take that 4 and substitute in. So I've got 2x plus 2 times 4 is equal to 22. And I've got 2x plus 8 is equal to 22. Subtract 8 on both sides. I've got 2x is equal to 14. Divide both sides by 2. I'm getting x is equal to 7, so I have 7, 4. So my point of intersection is 7, 4. If I were to graph these two original equations, right here, if I put them in slope-intercept form, found the slope, found the y-intercept, graph them, they would meet at 7, 4. Okay, let's take a look at one final problem, number 3. We've got 5x plus 3y is equal to -10, and 3x plus 5y is equal to -6. All right, so if I take a look at this problem, I don't have the same number for either variable, and I don't have opposite signs. So there's really no easier variable to eliminate. Well, we eliminated x in the last problem, so let's decide to eliminate the y. I've committed to eliminating the y. So that means 3 and 5 have to be the same number. So what I usually do is I go to the smaller number. Is there a number that I can multiply 3 by to get 5? The answer is no. So here's what we're going to do. I'm going to take both equations. I'm going to take this 5, and that's what I'm going to multiply the top equation by. I'm going to take this 3, and that's what I'm going to multiply the bottom equation by. That takes care of the numbers. Now, both of these are positive. Only one of them has to be negative. So either I could do a -5, or I could do a -3. It does not matter. It's completely up to you. Let's do -5. I just decided to do the top one for no particular reason other than it was the top equation. So this becomes -25x minus 15y is equal to 50. And then I've got 9x plus 15y is equal to -18. Okay, let's add this up. I'm getting -16x. The y's cancel out. And then I'm getting 32. 50 plus -18 is 32. Divide both sides by -16. I'm getting x is equal to -2. So now I'm going to take that -2. I actually have 4 options. I can do it here, 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 or here. These numbers are a little bit larger, so I'm going to stay away from that. I'm always trying to find the easier equation to substitute in for. So you can really choose either of these. It doesn't matter. I'm going to choose the bottom one. I'm going to take that -2 and put it right in for x. So I have 3 times -2 plus 5y is equal to 6. I've got -6. That should be a -6 there. Let's make sure that's clear. I've got -6 plus 5y is equal to -6. Then I'm going to add 6. I've got 5y is equal to 0. And this is fine. You can have 0 as an answer. Don't think it's a no solution just because it's a 0. So remember, we're writing our answer as an ordered pair because we're finding that point of intersection. Even though we're not graphing it, we're still finding that point of intersection. So it's at -2, 0. And that's solving systems of equations by elimination.